Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5 and now we would like to present an experiment 2, which is the determination of melting point using capillary tube method. For introduction, the melting point of a compound is the temperature at which it changes from solid to a liquid. This is a physical property often used to identify compounds or to check the purity of the compound. A pure, non-ionic and crystalline organic compound usually has a sharp and characteristic melting point, which is usually 0.5 until 1.0 degrees Celsius. A mixture of very small amount of miscible impurities will produce a depression of the melting point and an increase in the melting point range. Consequently, the melting point of a compound is, is a criteria for purity as well for identification. The melting point of an organic solid can be determined by introducing a tiny amount into a small capillary tube. Then it will attach to the stem of a thermometer in a heating bath and heat the bath slowly and observe the temperature at which melting begins and completes. For pure samples, usually have sharp melting points, for example, 149.5 until 150 degrees Celsius or 189 to 190 degrees Celsius. However, for the impure samples of the same compound met at lower temperatures and over a wider range, for example, 145 to 148 degrees Celsius or 186 to 189 degrees Celsius. There are two common methods for determining melting point. Firstly, we are using Meltem apparatus and Tiller tube setup. The general method is to heat the sample indirectly by placing the prepared sample either packed in a glass capillary or on a glass cover slip on a heated medium. There are other designs such as the Fisher-John apparatus. An important note that unlike boiling point, the melting point is relatively insensitive to pressure and no pressure correction needs to be made.
The materials of reagents or chemicals that we used while undergoing these experiments plus solid organic compound such as benzoic acid and salicylic acid. So as for the apparatus or glassware, we use glass capillary melting point tube, weighing dish, micro spatula, ruler, glove and weighing paper.
About 1.00 gram of impure benzoic acid and for recrystallization was weighed and transferred to a 125 ml Erlenmeyer flask. 20 ml distilled water was added to the Erlenmeyer flask and the mixture was brought to the boiling point by heating on the hot plate with continuous stirring. The mixture was gently browned until benzoic acid dissolved completely as shown. The Erlenmeyer flask was removed from the hot plate and the solution was examined if there are particles of benzoic acid still undissolved. Add water in small increments followed by gentle heat with continuous stirring. 15 ml of water was added to the mixture and the Erlenmeyer flask was placed on the countertop for 15 minutes if the solution is completely clear and no solid benzoic acid is visible. Solid crystal was collected by setting up a vacuum filtration on a properly fitted filter paper in a clean buncher funnel apparatus as depicted in a figure. Mixture in the Erlenmeyer flask was poured into the buncher funnel and the vacuum pump was started. Ensure that all crystals are scraped out of the Erlenmeyer flask using spatula or stirring rod. The Erlenmeyer flask with 5 ml of distilled water was rinsed followed by pouring it into the bunch funnel. The Erlenmeyer flask with the filtrate was carefully immersed inside an ice bath and leave the filtrate to recrystallize for 15 minutes. Solid crystal was collected by following step 5 until 7. The Erlenmeyer flask was rinsed with 5 ml of chilled distilled water followed by pouring it into the punch funnel. The vacuum pump was let run for a few minutes to start air drying the crystal. Then, a spatula was used to lift the filter paper and crystal out of the puncher funnel. The crystal on the filter paper was pressed as dry as possible with a large clean paper towel. The crystal was left for 15 minutes until they are completely dry. The dry crystal was transferred to a pre-weighing filter paper and the weight of the crystal of the recovered benzoic acid was determined.
So these are the results for the determination of melting point of benzoic acid and salicylic acid using capillary tube method. So as for benzoic acid, the melting point range for it changes from solid to liquid are 134 degrees Celsius to 136 degrees Celsius, and for our group 5, we got the melting point of benzoic acid is 134 degrees Celsius. Then for the salicylic acid, the range of its melting point to change from solid to liquid are 158 degrees Celsius to 160 degrees Celsius. Hence, we got the melting point of salicylic acid is 160 degrees Celsius.
Question 1 from experiment 2. The question is, define melting point of a substance. The answer is introducing a tiny amount into a small capillary tube, attaching this to the stem of a thermometer centered in a heat bath, shifting the bath slowly and observing the temperature at which melting begins and is complete. Question 2. What is the purpose of determining melting point? The answer is, melting point determination is the thermal analysis most frequently used to characterize solid crystalline materials. It is used in research and development as well as in quality control in various industry segments to identify solid crystalline substance and try to check their purity. Here, question number 3, experiment 2. What is the method not used for finding the melting point of inorganic compound? The answer is, the producer is not utilized to determine the melting point of inorganic compound is because inorganic compounds are often ionic and have extremely high melting point. There is no comprehensive table of melting point data of inorganic compound that exists for organic, despite the fact that some inorganic compounds are solids with accessible melting point. In general, melting point can be used to determine the purity of inorganic compound if they are accessible. Question 4. Why could the rate of heating influence the melting point? The answer is, this leads to decrease in force of attraction between the particles of solid. Therefore, the solid will start to melt, and this means that on increasing the temperature, there will be increase in rate of reaction. For example, ice being a solid matter, when heated, it changes into liquid water. Precaution experiment 2. First, always wear safety glass in the lab. Second, avoid skin, eyes, and inhalation contact with all chemicals. Handle all chemicals with care. Third, never insert a room temperature thermometer into a hot melt temperature. It may shatter. 4. Do not heat the melt temperature beyond the upper temperature of the thermometer. 5. Is do not leave the melt temperature on if it is not being used, and do not leave it on when untended.
I have to come to the end of our presentation, so I would like to conclude that our experiment goal has been reached. In this experiment, we are focused on the melting point. The typical definitions of the melting point is the temperature at which a substance transforms from a solid to a liquid. The melting point of a liquid is the temperature at which a solid transforms into a liquid at the atmospheric pressure. From our result of this experiment, the melting point of benzoic acid is 134 degrees Celsius and salicylic acid is 160 degrees Celsius. So, based on experiment findings, it can be said that benzoic acid reached its melting point more quickly. To protect ourselves from any negative outcomes, we should always wear safety goggles in the lab during run this experiment.